Can you see my slides?
Yes, Kiran, we are able to see.
Okay. Okay. I welcome you all and thank you for deciding to attend today's session. So my name is Kiran Marathe. I'm the founder of a company called DTRI, which is based in Mysore. So I welcome you for today's session, which is 5G connected car. And I'm going to talk about how it is a disruptive technology. So, Bhishma, what is the process? They can type in questions in the chat window.
Yeah. At the end of the session, we can take all the questions.
Okay.
If they have.
Sure. Okay, we can do that. Then I'll keep continuing.
Yes, please.
So firstly, some statistics on the 5G connected vehicles for consumers. So these are the statistics for, let's say, consumer side of things, say users like you and me who are planning to buy cars, which will be connected to a network. Okay, so you can see some numbers here. How the market is progressing in terms of connected automotive cars. By 2027 there are going to be some 831 million. So this is one just for the automotive segment, and then some user experience related statistics which all comes from Nokia, their research. Okay, so another statistics here, this is for the enterprise segment. So when I say enterprise, it is a B2B segment where let's say there is companies which are looking into fleet management and let's say logistics. So those are kind of companies which are looking to build a 5G connected device, 5G connected vehicle for their services. So again, these are some statistics based on the user experience from those companies. Again, this is based from the Nokia research. Okay, so now I see that there are about 60 plus participants. I just want to get a quick understanding on who is attending this session and to understand your background better. So can you please type in maybe in 3 words saying what you do and which is your company? And just give a minute there. I'll keep watching the chat window. Okay. Okay, very good. I got a lot of responses. So I see that almost all of you are from automotive background in different organizations, MNCs and bigger companies, and in various roles. Also, I see some of you are engineers, embedded engineers, manufacturing, a lot of different profiles. Okay, interesting. Okay, so this is a very varied audience, at least a new kind of audience for me. So I haven't addressed so many automotive engineers in the past. Okay, thank you very much for all your responses. Okay, so this is my question for you. So, as we progress through the session, please note down your questions. So like how Bhishma said, we can take up the questions at the end of the session. Let me go to the next slide. So anyone here has any working experience on any of the technologies like 4G, 5G, Wi-Fi? Can type in the chat window. Okay. So someone has experience on 4G core SIM, Bluetooth. Okay. G antenna, location. Okay, I see a lot of answers. So some of you do have experience working in 4G, 5G technologies. Okay, that's very good. So I see that you have, some of you have experience in these technologies, and most of you are from automotive background. Some of the topics you may feel that it is repetitive. So please bear with me, okay? And let's go through this session together. So first, before we get into the details, so let us start with 5G. Okay, let's understand some basics on 5G, and then connect it to a car. So that's how we'll progress. So this is again some statistics for you. So if you see what is the expected 5G penetration by 2025, and if you see that India is among the top 10 countries in terms of 5G network penetration. Okay, what it means is how many users within a country will be using 5G network. And this is not specific to automotive domain. This is in general the 5G penetration statistics for various countries. Okay, so before we get into 5G, let us look into the evolution of cellular technologies. So I'm sure that all of you have heard about 3G, 4G, and 5G, where G stands for generation. So it indicates that how the technology progressed from one generation to another generation. So let's start with the first generation, or the 1G technology. So if you look at 1G technology, I'm sure all of you know about analog and digital systems. So if you look at 1G, 1G was predominantly an analog system. That means there were no digital systems in that, and the focus was on voice communication. So you can look at some modulation schemes like frequency modulation, and AMS was one of the system which was working on the 1G system. So we cannot call this as a cellular technology yet, because it was still in the first generation. Then after 1G, we got into 2G, which is second generation of technology. So you can see here that the progression happened from an analog system to a digital system, and some new technologies came into picture like GSM and CDMA. And again, if you see here, the focus was still voice, but there was some minimal amount of data which was allowed. So 1G was mainly focused on voice communication. That means regular phone calls. While we went into 2G, there was little amount of data that came into picture. Let's say, for example, SMS. Then from 2G, the system progressed to 3G. So if you see in 3G technologies, again, it's a digital system. Some newer technologies came into picture like WCDMA, CDMA2K, TDS CDMA. And again, the focus here was voice, but slightly with data. So as we entered into 3G, voice was still predominantly there. It was being used for voice communication, but the focus also started getting towards the data part of it. So you can see here the data rate increased from 60 kbps to almost 2 mbps of data. So I have, if you see some terminologies here, I'm not going to expand all these terminologies. I'll just leave it to you. You can maybe note down and then also look up on internet. So you'll get details about all these technologies. Okay. So then we move from 3G to 4G. So again, it's a digital technology. And I'm sure all of you have heard of LTE, which is long-term evolution, which is basically a specification name is LTE, while we commonly call it as 4G. So here, if you see, we moved from voice to a data focused network. That means voice became a primary thing, or it was moved to a secondary function, while the primary function was data. So, and also you can see that the data rate improved vastly from 2 Mbps to 100 Mbps. Then today we are in the 5G era. So it is completely digital. So the specifications name for 4G was LTE, while for 5G, the specifications is NR, which stands for new radio. So new radio the focus is completely on data. Voice is still there, but voice is also considered as data in 4G and 5G. So you can imagine that everything is a data packet when you go to 4G and 5G technologies, and the data rate has hugely or tremendously increased, or that is a theoretical data rate. Almost we are moving from, let's say, 1 Gbps in 4G to almost 10 Gbps in 5G. Okay? So this is how the technology is progressed. Now there are some intermediate steps. Okay, so these are some bonus, let's say, technologies in between. So what happened is, when the generation was progressing from 2G to 3G, so there was an intermediate section called as 2.5G or 2.5th generation. So this was again a digital section, digital technology. So you can see here that if you have used 2G phones, you might have seen Edge and GPRS being used. So the difference here is you're going from a data rate of 60 kbps to a 2 mbps data rate in 3G. But obviously, technology cannot take a switch like that fast. So typically, any technology, any generation movement from, let's say, 2G to 3G or 3G to 4G or 4G to 5G, it takes a decade. It almost takes about 10 years to move from one technology to another technology. So the switch was not immediate. So there was an intermediate stage called 2.5G, where you can see that the data rate has increased from 60 kbps to like 384 kbps, but it is still not at 3G technology. Okay, so this is that intermediate stage. So similarly, we had a transition stage from 3G to 4G. So where there were new technologies introduced like HSDPA in case of WCDMA network. And you can see that the data network data speed increased from 2 Mbps to almost 14 Mbps, much higher than 3G, while it is still lower than 4G. Okay, so you can imagine that we are transitioning from one generation to another generation. So similarly, there is an intermediate stage. So you can imagine that practically we are today in this stage 4.5G. Even though we have 5G network even in India, obviously we won't be getting 10 Gbps of data rate. So probably we are slightly better than 4G, and maybe closer to 4.5G. Even 3 Gbps is a very highly optimistic number. I'm sure if you check your data rate, if you're having a 5G phone, I don't think so you'll be getting 3 Gbps of data rate. But we can say that we are in this stage where we are more than 4G and slightly less than 5G. So this was called as LTE Advanced, LTEA Pro. So this is an intermediate stage of between 4G and 5G. So this is how the technology progressed from first generation to fifth generation of cellular communication. So when I'm talking about cellular communication, so you can imagine that all the mobile phones that we use, the connection that we have is, you can call it as a cellular technology. Okay, I'll move to the next slide. So let me summarize what we went through in the cellular technology. So we had 1G, which was focused on voice communication. Then we had 2G, which was better voice, because we moved from analog system to a digital system in 2G. So the voice communication got better. And some data was introduced, like let's say SMS. Then 3G, voice communication was still there, but the data rate got higher. So we had some data and it got faster data. Then 4G, super fast data. So I'm again relatively comparing to 3G. So the data rate increased very much. You can see I changed the order here, because as we went into 4G, everyone was focused only on data, right? Voice communication became secondary. So 5G, it's huge amount of data and it's only about data. Okay, so 5G is only about data. So we are no longer thinking of voice communication as a primary function here. So if you look at it, all these generations from 1G to 4G, they were mobile phone focused. That means you probably had a 2G phone, then you bought a 3G phone, then you discarded the 3G phone, then you bought a 4G phone. Maybe you are going to discard it and you're going to probably buy a 5G phone, right? So that's how, as consumers, we are going to move from one generation to another generation by changing our mobile phone. But if you look at 5G, 5G is not only about mobile phone, it's about connected world. That means there are human beings, there are machines, everything is getting connected to a network. So that is what is a differentiating factor for 5G compared to the previous generations. Okay, now let us look at 5G. Okay, so today's session, since it's on 5G, let us focus on 5G. So when we are talking about 5G, what we should remember is it is broadly made up of three pillars in the network. So what I mean by that is, if you look at the previous generations, so when we moved from 1G to 2G to 3G to 4G to 5G, the progression was based on the data rate. That means the point was, what is the data rate that we are going to get by moving to the next generation of technology? So typically, if you see the generations, we probably had 10 times more data rate from one generation to another generation. Let's say that is some number 10x. That's what we were looking at. But if you consider 5G, the focus is not only on the data rate. So there are other two parameters or pillars of 5G. So that's what this picture represents. So whatever the data rate aspect which we are looking from each generation to generation, that is this pillar in 5G, which is called as enhanced mobile broadband. So this means that from 4G, the data rate or the broadband speed has increased. Hence, it's called as enhanced mobile broadband. But that is the only similarity that you can compare with the previous generations. Now, in 5G, there are two new things which were not defined in the previous specifications. One is massive Internet of Things. Second one is mission critical services. Okay, so what do I mean by these two things? So enhanced mobile broadband, we know that it talks about the data rate. So we moved from, let's say, 1 Gbps of data in 4G to 10 Gbps in 5G. Okay, so it's like a 10x increase in data rate. So massive Internet of Things. So imagine you have 1,000 or 10,000 or 1 lakh IoT devices. Internet of Things is IoT devices which want to connect to a network. Okay, so imagine you have these small devices in an IoT network which don't take too much of data. Okay, they don't take gigabytes or megabytes of data, but they take small amount of kbps kind of data, but they want to still connect to the network. So those kind of devices fall under this category where it's called as massive Internet of Things. Why it is massive? Because we are talking about probably lakhs of devices. Let's say 1 lakh of devices which want to connect to the internet. They may be small data rate. They may take small amount of data, but they are more in number. So that's it. That is massive Internet of Things. And the other pillar is mission critical services. What is the meaning of mission critical? So mission critical means we are looking at devices or services which require very low latency, okay, very low latency and very high reliability. So imagine this is a low latency and ultra high reliable communication system. Okay. I hear some background noise. Can you please mute if you're not talking? Okay, thank you. Okay, so that's how you can imagine that when you think of 5G, you have to imagine that these are the three pillars of the 5G network, which is very different if you compare to 4G. Okay, so now let us look at some examples. So when we look at enhanced mobile broadband, so the abbreviation is EMBB. It talks about high bandwidth or high data rate. So you can think of some applications like AR, VR, augmented reality, virtual reality, video streaming, online gaming, downloads. So these are some of the applications which we have been seeing already, right? So if you're using 4G today, probably you're already watching some Netflix or Prime videos online. You're probably playing some online games. You're downloading high bandwidth required, some data files and all that. So that you're already doing on 4G today. So what is the difference here is you're going to use 5G and you're going to get some, let's say 10x speed compared to 4G. Okay, that's what enhanced mobile broadband applications are. Now, let us look at massive Internet of Things. Massive Internet of Things or massive machine type communication, also it's called as MIoT or MMTC, which stands for massive machine type communication. Here you are looking at huge number of devices which are getting connected to the network. So some examples are, let's say, smart agriculture, smart metering, smart city. So one example of smart cities, for example, today in cities like Bangalore, what they're doing is they have connected these electric meters, which are smart meters, and the meter reading is not done by a human being. So the meter reading automatically is sent to the BESCOM or the electricity service provider. And you can imagine in a city like Bangalore, there are probably thousands or 10,000 homes in a given location. So all these meters have to connect to the 5G network and send the data. So this is a good example of, let's say, massive Internet of Things. Obviously, we are not using 5G yet, but you can imagine that this is an application of 5G. Okay, now example for mission critical services. So I told you that mission critical means you are, which is ultra reliable, low latency communication. So we are talking about reliability, which is, let's say, 99.9999. Let's say some 4 nines after 99. And we are talking about low latency. Low latency is like really low, less than like 1 millisecond. Okay, 1 millisecond of the network time. So we are talking about a very reliable network and a very fast network. So coming from an automotive background, I'm sure you understand the significance of URLLC, when you're doing some validation or when you're designing a product, right? So for you in particular, if you are in automotive domain, probably this is the pillar which is of most interest for you, okay, compared to the other two pillars. So I have given here like few examples, like it is used in autonomous driving. It can be used in oil and gas industries. It can be used in robotic surgery. So the reason being that, all these applications, if you see, they are, life critical. They are emergency kind of services. So that's why it is called as mission critical, because there is a risk of life. There is some danger that is involved. So that's where a reliable and a fast network comes into place. Okay, so to summarize, compared to 4G, you can imagine that 5G has these three pillars, and 5G is not only about high data rate, it is also about massive Internet of Things and mission critical services. Okay, I'll move to the next slide. Okay, so far we looked at, the 5G, how we evolved from 1G to 5G, like the cellular generation evolution. So now let's look at high level architecture, like a quick overview. Okay, so if you have worked already on 4G or 5G in the past, I'm sure you understand this picture. But what I want to show here is, imagine this is your device, 5G device or 4G device, and this is the tower that you see. Like these are those big towers that you see outside. And this is something called a core network, which you cannot see because this is connected in the back end from your tower to the core network. So what you see is this device, and this device is called as UE or user equipment. And what you see here is the tower, which is called as radio access network. So this is the tower and this is the core network. So when we talk about 5G or when we talk about any connected car or connection, we are talking about this connection here. So if you're talking about connected cars, you can imagine that this UE or the user equipment, instead of a phone here, it will be a car or a truck or a bus or whatever it is, right? Any automotive device here, which is getting connected to a tower. So this is a simple example or to show that how a 5G architecture looks and what is the meaning of a connected car. So when we talk about connected car, we are talking about this connection happening, because this connection is already there and it does not depend on what kind of device connects here. Okay, the devices here, when we talk about UE can keep changing. It can be a mobile phone, it can be a laptop, it can be a car, it can be an IoT device, it can be a robot, it can be a machine, it can be anything here, right? And that is what connects to the network. and this is is always there, and it does not matter. Hope I am not getting into too much details or anything. You can let me know over the chat if this level is okay. Okay, let me continue. Now, since we have seen the architecture, let's look at the deployment options. Okay, so what is meaning of deployment? So we all have heard that 5G is getting deployed, or 5G is being rolled out in India, right? You might have read the news that Reliance is rolling out 5G in so many cities, and Airtel is rolling out 5G in the cities. So what we have to understand here is there are two kinds of architectures today on how 5G is rolled out. So one is non-standalone, which is also abbreviated as NSA. Other one is standalone, or SA. So if you just look at the English meaning, you can make out what is the difference. So non-standalone means that the 5G is not standalone. It is dependent on something else. While standalone means that 5G is an independent 5G network. Okay. So if you see this picture, right, this has to be 5G, right? I told you that this is a 5G network, but you can also see that there is some 4G aspect to that. And this blue box is connected to the green box, right? This blue box represents, all these blue boxes represents something to do with 4G. And this green box is the one which is 5G. If you see that this connection still exists, okay? That means today, the deployments or the rollouts that we have for 5G in India and even in Western countries is mostly based on non-standalone. That means there is a portion of 4G network which is working in the background, giving you a 5G connection. So it's not a pure 5G connection as we are imagining it. There is a 4G network and the 5G is on top of it. So that's what is non-standalone network. Now, if you compare it with a standalone network, you can see here 4G is independent and 5G is independent of its own. So this is a pure 5G network. Okay, and you may ask me why we are doing this. So as you know that transitioning from one generation, let's say from 4G to 5G, is like super expensive. Okay, so for the operators, let's say Airtel or Jio or BSNL, if they want to migrate from 4G to 5G, it is going to be super expensive affair for them. So what they are doing today is they are using the existing 4G network, and on top of it, they are providing you 5G services. So if you remember my previous slide where I showed you about URLLC, MMIoT, massive machine type communication or massive Internet of Things, and EMBB, which stands for enhanced mobile broadband. So all those three pillars, right? If you want all the three pillars to meet your requirements, right? So let's say if you're from an automotive background, if you want to look at ultra high reliability and low latency communication, then you need a pure 5G network like the one which is shown here. So today we are in this stage. So EMBB is probably possible, but still URLLC is still way far to go. Okay, it's a long journey we have to take. I hope I'm clear so far. So I'll move to the next slide. Okay, so far we discussed about 5G. So now let's connect 5G to the car. Okay, so when we talk about connected car, there are two major aspects. So one is telematics and the other one is infotainment. So let us look at what are these two things. So first, let us look at the telematics aspect. So telematics, it comes from combination of two words, So, there is telecommunication and then there is informatics. So basically it's a mix of communication systems and information science topic. So think of this as a system which manages, a lot of critical safety related information, maintenance information, servicing, billing, performance data, about all the safety, maintenance, service, billing, which is related to the car. So think of an example like an ADAS, which is Advanced Driver Assist System, where telematics may be used. For example, telematics may be used in ADAS to make some decisions. Okay, so that's why it works in the background. So users don't have control over it. So they can't control some aspect within the telematics aspect. So users don't have control while it is used for other purposes. So users, how will they know is maybe there is some indication. Let's say a maintenance is required or a service is required or something is breaking down. Then probably the users will know. So it's mostly an indication for the users, but they don't really have control over this system. So you can imagine that it's a duplex system. So what I mean by duplex here is it's a two-way communication system between the car and the network. So it connects to the outside world, and that is a two-way system. So some information is sent from the car to the network to, let's say, the manufacturer or a service shop or something. And then some information may also come from the other side to the car. Okay, so that's what is duplex communication here. So you can think of this as a B2B, that is a business to business kind of application. That means companies which are looking into fleet management or let's say vehicle management or logistics or vehicle tracking. So these are some of the companies which could be interested in using telematics as a service. Okay, so some examples are, let's say the best example is, for example, there are multiple over-the-air updates that happens to numerous ECUs in a vehicle. So you can imagine that all this has to happen without involving user into the picture, and all this can be done, let's say, using connection to an external world. Now compare this telematics with the infotainment. So again, infotainment, it's a combination of two terminologies. It is information plus entertainment. So what do you mean by information? So information can be any general information, like let's say the news or the weather or location. So it can be any of those general information, or it can be also some information relating to your car. Okay, it can be your car performance in terms of interiors. Let's say how your what is your AC temperature, what is the what is the seat reclinement and all that. So it can be that kind of information also. So obviously there is user control here, because user is the one who decides, okay, what kind of information I want or what kind of entertainment that I want. Okay, so you can imagine that user has control, and it's a simplex communication. What a simplex communication is, it's a one-way communication. That means, let's say you want to change the AC. Okay, let's say you want to change the temperature. Then you basically click on some kind of a service or an app and saying that, okay, I want to change the AC or the temperature. Okay, and then there is nothing two-way happening there. So you can imagine that it's a one-way kind of communication, and it's focused on within the car. That means all the communication that we are thinking of from an infotainment perspective is internal to the car. And B2C companies, that means businesses which wants to talk to consumers, let's say like you and me, are the best examples of infotainment service. Okay, so maybe in future, if I want to plan, if I plan to buy a new car, maybe the dealers are going to say that these are some of the infotainment features that you are going to get within the car. So that is going to be a key selling point for dealers and companies. Okay, so with all your I see that initially I saw the chat messages from you all, that you all come from automotive background. So I'm sure that you know more about telematics and infotainment than me. So my previous slides were just a quick recap of what you already knew. But what it takes to connect to the external world when we talk about infotainment or telematics is connectivity. Okay, and that connectivity has to be a wireless communication. So whether it is communication from external world to the car, or whether it is interior to the car, that means within the car, a user communicates and gets some service. This is within the car, or a use case where the user wants to connect to the external world, but he has to go through the car. Okay, so you can imagine that these are the three scenarios where, let's say, this is a telematics kind of an example. This is an infotainment, and this is again telematics. Let's say the user wants to make a call. Okay, the user wants to make a call to another person who is outside the car using 5G network. In that case, he has to go through the car, and then the car will connect to the external world. So all this, you can imagine that it happens through a wireless communication. And think of connectivity as the blood cells in your body, blood vessels in your body. So why I'm saying it as a blood vessel is it's a two-way communication, right? So how blood vessels carry your blood from the heart to all parts of the tissues, and again the blood goes from tissues back to your heart. You can imagine that connectivity is again a two-way system which carries information to various aspects between users, between the car and other users or the external world. So to for this connectivity to happen, let us look at some major devices which contribute to connectivity. Okay, so one is antenna. So I saw that already in the chat window. Someone said that they have worked on antenna. So for any wireless communication to happen, you require an antenna. So today, if you see your mobile phone, you may not see an antenna externally, but in the previous days, in older phones, you could see a small thing protruding on top of your phone, which was an external antenna. So same thing today, if you see your wireless Wi-Fi router at your home, that also has external antennas. Some of you who may not see the antennas, it's probably internal to your device. So antenna is a very critical device which is required to communicate wirelessly. So what is other technology? So Bluetooth. So while we are talking about 5G, Bluetooth is another very short range communication system which we all use today, right? So you may be using it for your airports or wireless earphones that you have today. So most of them use Bluetooth technology, and it's also used within the car. So GNSS, all of you have heard about GPS. So GPS is a very US specific technology. The generic term is GNSS, Global Navigation Satellite System. So it encompasses all the navigation systems. So you know very well that GNSS is used for location, and location is very critical, especially in case of a mobile device like a phone or a car. Then next is Wi-Fi. So we all know what is Wi-Fi. So we have been using Wi-Fi. So Wi-Fi is again a connectivity technology. It is not long range as 5G or 4G, but it is much better than Bluetooth. Audio. So audio is even though it's not a I cannot call it as a RF kind of a technology. It's a very low frequency technology, but within a car it has help. It is a very helpful technology because many of the services or applications are enabled or disabled using the audio commands. So that's why audio is another wireless technology here. Then FM AM radio, I don't think so FM AM radio is going to go away anytime soon. So in spite of all the mobile phones 5G that we have, still cars come with AM FM radio. So that's another wireless technology. So finally, we have 5G, which probably is the technology which has the most range, which can take a lot of high data communication, which you can imagine has much high reliability. In terms of security, it is much better than any of these technologies, and it also has a very low latency. That means the delay is very low. So 5G is a futuristic technology because you can basically do everything which a Bluetooth or a Wi-Fi could do today with 5G. Okay, so when we are talking about connecting to external world wirelessly, there has to be some globally accepted specification, which we can say standardize across countries. So if we look at globally, you can look at there are 4 types of communication connectivity configurations. One is V2V, V2I, V2P, and V2N. So here obviously V stands for vehicle, and other part of the two is basically comes under V2X. So X can be any of these V or I or P or N. So all these are cellular V2X configurations. So let us look at each one of them quickly. So V2V stands for vehicle to vehicle communication, which enables information exchange wirelessly between two vehicles. Let's say two vehicles are going next to each other, and they want to share the speed information or the location or where these vehicles are heading, right? All that information can be shared between two vehicles. So that is V2V. Now, in a V2V scenario, the vehicles basically broadcast messages and it receives messages in a 360 direction. That means you are talking about vehicles which are sending information and also receiving information in a 360-degree angle. That means it has all around awareness, okay, omnidirectional awareness about other vehicles around it. And based on that awareness, it can create some alerts. It can tell the driver that okay, you have to take some preventive action and all that. So the only drawback or the challenge with V2V is that let's say you're doing V2V with this vehicle, it's not sufficient if you have V2V protocol on this. You need to have V2V even on this protocol. That means we are looking at an ecosystem of connected vehicles where every vehicle on the road needs to have a V2V protocol. Okay, so let's next go to the V2I. So here I stands for infrastructure. So we know what is V. V stands for vehicle. But what is I? What is infrastructure? So when we talk about infrastructure, we are talking about, let's say, physical things that make up the road system. So it can be anything which can be traffic lights or let's say roadside barriers, street lights, traffic signs, lane markings, footpaths, zebra crossings. So anything that comes under a road system, you can call it as a V2I or an infrastructure related system. Okay, so V2I falls under what we call as intelligent transportation system. So the catch here is that again, similar to V2V, to make V2I work, you need the infrastructure to be very robust. That means the lane markings, the pedestrian crossings, the footpaths, everything has to be very well maintained. Okay, so that infrastructure has to be in place for V2I to work. Okay, so the next one is V2P. So we know what is V. V stands for vehicle again, and P here stands for pedestrian. So already in V2I, we discussed where I is infrastructure. So one thing which we didn't cover, everything will come under I, but one thing which doesn't come is pedestrians. So you can imagine that V2P is kind of a subset of V2I because imagine that you have human beings who are obviously not part of the infrastructure, because infrastructure, if you consider, let's say you're talking about a traffic light or a street light or a footpath, right? All those things are stationary, while pedestrian communicating with a vehicle which is also probably moving and a pedestrian who is also moving. So here you're doing a communication between two mobile devices, and here it's probably one of them is stationary. Okay, so you can imagine that V2P is assisted by V2I. That means if a pedestrian is going to cross the road, imagine that he's going to cross on a zebra crossing. So using V2I, the car will know that in next 100 meters, there is going to be a zebra crossing. Okay, so using V2I, the car will know that, okay, there is going to be a zebra crossing. And it can expect that there is going to be some pedestrian who is going to cross there. Okay. Also, using V2I, the car knows that there is a traffic light which is going to turn red. That means it can anticipate that, okay, there are other cars or pedestrians who are going to cross the road. So same way, V2P, can give information saying that there is a zebra crossing, or there is a footpath, there is a cycle lane, there is a school zone or playground, or whatever, right? All that is used to make the decision in a V2P system. Now the last one is V2N. So N stands for network. So it can be you can imagine that vehicle connects to a generic cellular network. So here N can be 4G network or 5G network, any network that you want to cover, that you want to connect to the car, right? So that comes under this V2N. Okay, so at a high level, so these are the 4 configurations. So what I want to tell you is, there were 2 specifications bodies which were looking into V2X communication. So where X stands for V, I, P, or N. And all these configurations that I discussed is from a specification body called as 3GPP, which stands for Third Generation Partnership Project. And 3GPP is the body which defines specifications for all the cellular technologies like 4G, 5G, 3G. Okay, so we are going to look at 3GPP specifications, but there is some history to that. Okay, that also I'll explain you. So 3GPP specification, which is cellular based, calls it as CV2X standard, and it is based on NR. So NR, I told you, it is new radio, and this is the specification number 22.185.186 numbers, and it has a higher range than DSRC. So I'll tell you what is DSRC in a minute. So this is the spectrum that is allocated. So if you remember that any communication, wireless communication, it works on a particular spectrum or a set of frequencies. So today, if you're talking 4G or 5G, obviously there is a particular set of frequencies which is allocated to your mobile device over which the communication can happen. So similarly, 3GPP has defined for V2X applications, this is the band that it has to use. Okay, so the limitation is limited bandwidth. So I'll also tell you what it means. So before that, let us look at some history. So IEEE, which is another organization which looks into advancement into electronics and electrical and computer science areas. So they came up with a WLAN or a Wi-Fi based V2X technology, which is called as DSRC. So DSRC stands for Dedicated Short Range Communication. So back in 2000s, early 2000s, so they came up with this technology where they said that, okay, we will use this technology to do V2X communication. Okay, so it is based on 802.11. So if you see your wireless routers today, they are also based on 802.11. So very similar. This number is different. So you might have heard of 802.11.N, A, B, G, and all those numbers. So P stands for the V2X standard in IEEE. So the range here is limited because it's a Wi-Fi based technology. The range is not much, only 300 meters compared to higher range in 3GPP because you are using 3G or 4G here. So the range is much higher. So imagine, compare your mobile phone with a Wi-Fi router. Okay, so let me discuss about the 5.9 gigahertz. So when the 5.9 gigahertz spectrum was released, okay, this is mainly in US and Europe. Okay, India, we don't have, I don't think so there is a band decided yet. In US and Europe, this 5.9 gigahertz was not specifically given only for this. It is also given for DSRC based technologies. So that means 5.9 gigahertz can be shared by 3GPP and by these standards. The other advantage with IEEE is they also have the unlicensed Wi-Fi band. So if you imagine within the car, if you are within the car, you can use your regular Wi-Fi. Regular Wi-Fi works at a different band. It does not work in this band. It works, let's say, in 2.4 gigahertz band. So regular Wi-Fi can still be used on the unlicensed band. While if you want to do a pure, telematics kind of an application, then you have to use these frequencies. Okay, what do I mean by limited bandwidth? So if you remember my 3 pillars of 5G, I told you that EMBB, which is enhanced mobile broadband, talks about very high data rate. So to achieve very high data rate, let's say 10 Gbps or 5 Gbps kind of data rate, you require very high bandwidths. But unfortunately, the US and Europe, when they released the spectrum for V2X, they did not release a large amount of bandwidth. It's a very small set of frequencies that where they have released to V2X. That means because of limited bandwidth, there are only specific applications that you can do. You cannot fully use the all the use cases because of the limited bandwidth. Okay, so finally, one note: IEEE based, or any DSRC based technology is almost dead. So the only technology now is 3GPP based. So all the countries, US, Europe, India, all the countries are following 3GPP based NR standards going forward. So the last thing to discuss, how is 5G disrupting the auto industry? So the title of this presentation is that it's a disruptive technology, right? I said that 5G is a disruptive technology. So we have to understand, okay, what is the disruption here? So in the initial 2 slides, I showed you statistics about consumer devices and enterprise. That means B2C and B2B. So here, I'll tell you what is a disruption that you can imagine will happen in a consumer case, like you and me, okay, who are buying the connected cars. So what is the disruption? Why should we buy connected cars? Okay, that's what I am going to focus on this slide. First, think of a mobile phone that you have. Okay, so what do you do with your mobile phone? You probably watch videos, you read stuff, you chat with people, you create content, you watch photos, you create videos, you play games, right? Lot of things that you do on your mobile phone today. Now, next is your home. Imagine that you have a smart home. That means you have electrical, mechanical gadgets in your home like TV, washing machine, AC, water motor, CCTV, lighting, coffee maker, oven, whatnot, a lot of things, right? So everything today can be connected to the network. So think of, your mobile phone where you do a lot of things, and think of your smart home where you have a lot of devices which you control. Now, what if we combine these two? What if we combine these two? Okay. And then we create a new technology. But where are we going to use that technology? Okay. Imagine you are traveling alone or with your family, friends, relatives in a vehicle. Okay. And that vehicle can be a sedan or an SUV or a MUV or a truck or whatever it is. Now imagine if you can combine the services or the convenience that you get from a mobile phone and the comfort that you get from a smartphone, okay, within a car, okay, within a vehicle. So that is the disruption that's going to happen. So imagine you want to watch TV, you want to watch movies, you want to order something online, or you want to take a meeting, or you want to talk to someone inside the car, or let's say you want to control some gadget at your home remotely, right? Imagine doing that everything sitting in a vehicle. So, and like a mobile phone, you're also moving. So imagine you are moving in a vehicle, you're doing all that you could do in the mobile phone and all that you could have done in a smart home. So imagine combining all these things in your car. So basically, you have converted your car and you have got your comfort from the home and the connectivity that you would have got from your mobile phone in a connected car. So this is the kind of disruption that the automotive industry is looking forward to. They are imagining that you are in a vehicle, so that is like your home. The exterior of the vehicle provides you the comfort of your home, while you get connected to the external world, using your mobile phone technologies, which is 5G. Okay, so this is my last slide. I think we are almost there time. So we are probably 5-6 minutes. So we can take questions now.
Yes. Thanks.
So Bhishma, I can open the chat window and I can read out, right?
Yes, please check.
Okay. Okay, so let me read the questions. Okay, let me start with the first question. Is 5G is using all over the world? The radiation is also high, right? And is there any possibilities to reduce the radiation? Okay, so this is a very common question that I get about radiation. So it's not only about 5G. Okay, so people are being misled today that 5G is causing a lot of radiation. So today the transmit power from 5G is very similar to 4G. There's not much difference because it's the same band and same set of frequency bands and power levels are being radiated. And like how I told you, 3GPP is a specifications body. So obviously there are specifications around how you have to design your product, what should be the radiated port. So everything is decided. So it's not that 5G is going to cause something, some new thing which is going to radiate more. Okay, and as you know very well, we are surrounded by wireless devices, so we can't really eliminate wireless devices. It's not only about 5G, right? You also have this high power transmissions from TV or from radio, and then you have Wi-Fi around you, Bluetooth, GPS, right? So many wireless technologies are there around the world. So don't worry about too much about radiation, because if we want to adopt newer technologies, be a wireless world, so there are going to be new technologies that will going to come into picture. Okay, many good things are being done by agricultural engineers currently in India using IoT methodologies to solve issues. Much of it is in 3G and 4G. Okay. Also use 5G. No, LoRa is a LoRa is mostly based on unlicensed band. Okay, that means it uses a Wi-Fi kind of band and it's not based on 5G technology. LoRa may use 5G because LoRa is again not a long range as 5G. Okay, someone asked about agricultural. Can we use 5G? Yeah, we can use 5G, right? If there is a need, you can use 5G, not necessarily. Cyber security will be prominent in this case, and all systems you can model. Yes, that is true. But cyber security threat was always there, even in the previous generations. So what is new is if you are comparing, let's say, Wi-Fi, right, kind of a technology, and 5G. 5G has a much better. The protocol stack is designed much better, so that you have a better secure system compared to Wi-Fi. Disconnected in area. Okay, I don't know. Okay, someone is asking after 5G upgrade from Geo, frequent call is disconnected in my area. So I don't know that Prashanta Kumar, why it is getting disconnected. Maybe network issue or the device issue. Okay, what use cases we can cover under URLLC for automotive, apart from HD map and video streaming? Okay, autonomous driving is a very good use case for URLLC. What are the immediate solutions for connection that can be expected in the market? So there has been a lot of discussion. A lot of companies like Ericsson, Nokia, Qualcomm, Huawei, and car companies like GM, Ford. They have been all working on this connected vehicles concept. I think they are trying to see a right market fit on where they can use these technologies. Okay, will LoRa be completely eliminated with 5G in picture, or is it no? So LoRa and 5G, it's not going to replace one another. So think of LoRa as a communication, as an alternative technology. Okay, and 5G. See, imagine 5G has its own advantage. Okay, so let's say you are connected to a LoRa network, and let's say you want to connect to someone from, let's say, India to US, right? 5G can do that. So it can give an end-to-end connection from India to US. A LoRa cannot do that for you, right? So imagine that it's a parallel technology, but for different applications. What are the opportunities and technical challenges faced by companies to transmission into? Okay, which kind of companies? Can you type, Rahul? How can we manage the transition where some vehicles are connected capability and if you are still not one that way? Yes, that is true. So for V2X to work, like how I told you, for V2V to work, all the vehicles have to be connected vehicles. 4G backend, correct. So that's why the switch is not going to be. So the question is, what is the challenges to move to completely to 5G network? So that's going to take some more time because it's a huge investment for the companies. So they don't want to invest in that immediately because almost 90% of the customers even today are still on 4G. So they cannot tell them to switch overnight to 5G, right? And people are not going to switch that easily. So it is going to take time. It's going to probably take another 1-2 years for the complete rollout of 5G. Europe, China, US. US is also focusing on C2VX, CV2X. How do we handle way to pedestrian communication? Okay. Vehicle to pedestrian can happen in 2 ways. One, vehicle may independently detect a pedestrian using cameras. Okay. So it can detect through image processing, it can detect that, okay, there is a human being. And it can also take the help of V2I, where infrastructure will tell you that, okay, there is a pedestrian expected at this spot. And the other way they are thinking is to have an application on the user's phone. That means the pedestrian's phone will have an app. Okay. And if that app is turned on based on the location, the user may also get a alert saying that there is a car coming in your way. So that is also going to happen. So the app is going to be both with the user and in the car. What are the certifications in field of 5G for automotive telephone? Okay. So when you come to 5G, so for any product, any wireless product to be released in the market, there are standard set of certifications. So for example, 3GPP is a specifications body. So any product has to first meet that. And on top of that, country specific, there will be specifications. So for example, if you have to go into US, you need to have FCC certification, for example. Okay. So that is very country specific. So here in India, we have something called as WPC, Wireless Planning Commission. So we need that certification for a wireless device. So that is very country specific. For V2V to work, will their OBDs be communicating or will the central computer that will generate have okay. So for vehicles to work, right? Onboard diagnostics is one thing. So you need another computer, let's say another processor, because when you introduce 5G into that, you need a modem. So you need a processor which does the modem functionality, and that has to communicate to your automotive processor. Release 16 of 3GPP. Okay, release 16 of 3GPP. I don't know. I have to check. I'm sure I have to check if release 16. 5G. Okay, 5G. Okay, I'll answer this question in two ways. So release 16 of 3GPP is supported on modules like Quictel and Continental modules. But if your question is whether it supports V2X, then you may have to check their data sheet. In-vehicle communication, how different is from V2X? So V2X is external, right? So the question is in-vehicle communication, how is it different from V2X? So V2X is vehicle to vehicle. That means you're communicating externally. So in-vehicle is within the vehicle. So a lot of cloud computing and data science would be involved, the transition. So if you're talking about cloud computing, unless you see a lot of processing can happen inside the car, but maybe for some autonomous driving or something, I don't know, you may need some cloud computing. That means you may have to connect to cloud. So that's where your URLLC comes into picture. That means you're talking about low latency communication there, because you have to communicate to a cloud for some operation to happen, and that decision or that information has to come from cloud to your car. It's already, I mean, wireless communication is already there in vehicle communication. So typically today, Bluetooth and Wi-Fi are being used. Can we expect a single onboard computer to be the only processing in the vehicle? No, that cannot be the case because at least for 5G, you need its own processor. So at least that processor is required just for the connectivity aspect of it. Okay, I think that was the last question. Any other questions you can type in? I have just 2 more slides. So this is a little bit about our company. So DTRI, we are an upskill and design company. So we are based in Mysore. So we focus on RF, 5G and IoT technologies. So we do upskill both for companies and for individuals. So we have our own hardware kit for all 5G and RF and IoT. And we also deliver that to your place for our online sessions. So you can contact us through any of these means. You can WhatsApp, you can send an email, or you can also call us on these numbers. So if you want more details, and even today's session, if you have any questions also, you can drop us a message or send us an email. This is a little bit about me. I'm not going to take much time. So currently I'm founder of DTRI. I'm also an RF architect consultant for Airtel and a 5G company. So I've worked at Intel, Qualcomm and L&T in the past. So my experience is in microwave engineering and wireless communication. That's what my master's degree is. And my specialization is RF system design for 5G and Wi-Fi technologies. Okay, so